Something that is important in science is reproducibility. If we take somebody's data and their methods, we would want to be able to get the same results. If we're not getting the same results and the data are identical, something is wrong about the methods and how they have been described. Maybe a step has been missing. Maybe you'll be able to figure it out later. It'd be a lot easier if we had the code that was applied to the data to get the results. Then we could always use that same code and apply it to new data and get results that can be interpreted based on the methods that have been captured in the code. So unsurprisingly, I'm a big fan of using code to improve reproducibility. I'm certainly not the first one. John Clairvaux, a geophysicist, wrote this quote that is given here, that an article about computational science in a publication is not the scholarship itself, it is merely the advertising of it. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. There are a number of things in here. First is that publications should include data and code. There's an example by Okada, who developed a method to model the ground motion due to slip on a fault, right? So we have an earthquake, the fault slips, and that means the surface is being displaced in some way. His analytical expressions captured that, and he provided Fortran code that was well tested, that implemented it, and that code is being used to this day. It didn't really come with a paper, but he freely distributed it, and folks still pass it around. Another point is that figures should be reproducible by readers. The notebook environment that we're showing here is actually quite useful for that, because you can have text, and then, as we'll see later down here, you can embed code, run the code, and that code could be very complicated. It could be loading data, do some analysis, show a figure, and you can have multiple code cells, etc. We'll talk about the details of notebooks later, but in a sense, they approach and were developed to make science more reproducible and allow readers reproducing the figures that are shown in the paper, perhaps, but also then experiment with the code and see how the methods work under different circumstances. And the last one is that you should write code that others can use. And that means many things, right? But to first order, it means that the code must be legible by a person, not by a computer. There are two examples down here that I'm showing. This is old MATLAB code. The details don't matter, but I hope you'll agree that if you look at this piece of code, it is well structured. There is, some kind of heading here, which is a function definition. Then there are some lines that have a funny percent sign here, which is a comment, meaning this text isn't being interpreted by the machine, and instead serves as commentary to the user what this function does and what the input is, or what format the input is. And then there's some actual code down here. There's an if and something that happens in the if statement, and else that happens in the else statement. So if d is not equal to 0, we'll do this. If it is equal to 0, we do that. Now, this piece of code here does the exact same thing, and it is functional in MATLAB. It does not require the kind of formatting that things are on a new line. It doesn't require any comments, which are just for the reader. I hope that you'll agree that even though this is more compact, it is going to be a lot harder to understand. Okay, so both codes do the same thing. They're syntactically correct, meaning that the interpreter, the machine, knows what to do with them and isn't going to say, oh, this is a statement I don't know anything about. But one is clearly more helpful than the other. So you should be striving to write code that looks nice, and still does the job, but also communicates a lot of information to the future reader, which, by the way, is going to be you too. And you will be surprised how quickly you forget what stuff like this actually meant and what you intended to do. It can be a month, it can be a year, but you will forget what that actually meant. And then you have to thank your past self that they took a shortcut instead of writing things out nicely. Something to be very mindful of in Python, which we are using here in this course a lot, is that it requires you to format well. So here's a piece of code that is required to be formatted that way. We are declaring a variable x. We are setting the value of it to 1. And then we are testing if x is 1. Then we're printing yes, and we're printing x is 1. And you can already see the output down there. There we have it. X is 1. Okay, so we can test this now and say x is 2, and nothing is being printed. We can change the code to say else print x not 1. And now the code tells us that x is not 1. Now, what happens if I do this? I get an error. You will get an indentation error, expected an indented block after else statement on line 5. Okay, so we'll make that go away. And that works, but it's not, the notebook here highlights this already, right? So if we're having an if-else statement, we want to indent them the same way. If we do this, we are getting invalid syntax because not because we are not indenting here, but because Python thinks that we're done with the if statement. This is outside of the if, and now there's an else that doesn't have an if. And what all these ifs and elses mean, we'll talk about later. The key thing to remember here is that formatting is important in Python. And the second example hopefully drives this home very clearly. If we set x to 1 here and we execute it, we get the same output as before. But as I stated up here, removing the spaces before this print closes the if statement. So if we set this to 2, we still get that x is 1. Despite us saying that, or thinking, writing it even out, that we intend this to be written only when x is 1. But the computer doesn't care. All the computer cares about is that there aren't spaces here. Therefore, this print statement isn't inside that if, and it's going to be printed no matter what the value of x is. Okay? You can find this notebook in the GitHub repository under notebooks, lecture 1, philosophy. You can play around with this either during lab time or as an example, and see what you can do with it. Don't be afraid. You can always delete it and load it back. You can change what is being printed. You can change when X should be doing, or when this if statement should be executed. And so just have fun with this and see you next week.